Hello, friends. Welcome to my channel, Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning exercise 4.3 from the chapter Determinants of class 12. In this exercise, we will be learning about finding the area of a triangle. This whole exercise is fully about finding the area of the triangle with different methods, but only one formula we have learned now. Using that formula, we will be finding the areas and the questions will be different. We have some 5 or 6 questions. So let's see that. Question 1. Find the area of the triangle with vertices at the point given in each of the following. So here coordinates, 3 coordinates are given. I already said you in the introduction part that 3 coordinates will be given and we will be asked to find the area of the triangle. So already we saw the formula. So what was the formula? Determinant is equal to half of x1 y1 x2 y2 x3 y3 1 1 1. This was the determinant to find the value of or the area of the triangle. No, so now this will be x1 y1 x2 y2 x3 y3. So now let's find the solution. So now I'm going to substitute in the formula. So half of, so what was my x1? 1, 0, 6, 0, 4, 3, 1, 1, 1. So this is the determinant. So now as I taught you already in the previous exercises, that is 4.1, I said no, we will be taking the column which has more number of zeros, or else we will be taking the column or row which is very easy for us to do the calculation. So here if I see this column 2, it has more number of zeros. No, 2 zeros it has. So I'm going to expand this determinant through column 2. Okay. So if I expand through column 2, so determinant is equal to half of, so I will be skipping these 2 zeros. Why? Because 0 into something is always 0. So now I'm going to check this position. This is 3, 2. The position is 3, 2. No? So 3 plus 2 is 5, which is odd. So it will be negative. So minus 3. And the determinant over here, it is 1, 1, 6, 1. So now I will be simplifying this half of minus 3 into, I will be using x method. So first 1 ones are 1 minus 6 ones are 6. So determinant is equal to half of minus 3 into minus 5. So determinant is equal to half of plus in minus into minus is plus. So 3 5s are 15. So the area of the triangle is 15 by 2 square units. So always the area will be in square units. No, so it's square units. Subdivision 2. Again, these 3 coordinates are given. Now we have to find the area of the triangle. Solution. First, we'll write the formula. So, determinant is equal to half of x1, y1, x2, y2, x3, y3, 1, 1, 1. This is the area of the triangle. So, now here it is x1, y1, x2, y2, x3, y3. Okay, so now I'm going to substitute in the formula. So area of triangle is equal to half of 2, 7, 1, 1, 10, 8, 1, 1, 1. So now let's see, I have one more method in order to expand. Just see this method. If it is confusing for you, you can go for the normal evaluation of the determinant. Just see, I don't have any zeros in this determinant. So if I have zeros, it will be easy for my calculations. No. So now I'm going to make something as 0. So what will I do to make 0 means I will be subtracting or adding in order to get my determinant, any elements, any two elements as 0, any one or two elements. Okay, so now I'm going to make, what I'm going to do here is that I will be subtracting this column from this column. These two columns I will be subtracting in order to get my element here as 0. Okay, so if I subtract these two, I will have this 0, no? So 1 minus 1 is 0. I will have here also 1 minus 1. If I subtract, I will have 0. So I can do it either in column or row. If I start doing in column, then I have to do in column only. There's some rules. Okay, so if you have watched that properties video, you will be very clear. So now I'm going to subtract these two. So I will now I will be doing it. So I will be subtracting. Column 1 implies column 1 minus column 2. Okay, so these two I'm subtracting. I cannot just subtract 1 and 1 and write 0 over here. I have to subtract the entire column or entire row. So now I'm going to take for this also 1 minus 1, I will get 0, no? So I will take 1 minus 1 as 0. So I will have column 2 as column 2 minus column 3. Okay, so now I will have determinant is equal to half of. So why am I doing here like this? Because I have to have some zeros, no? Or directly I can do, but the calculation will be little long. So only I am doing it in such a way. So 2 minus 7 is minus 5. 1 minus 1 is 0. 10 minus 8 is 2. Fine, this one is over. This is column 1. So now I'm going to do for column 2. So here also I have to subtract, no? So 7 minus 1 is 6. 1 minus 1 0. 8 minus 1 7. 1 1 1. Okay, so here if you want to make these two elements or these two elements as 0 also you can do, but you cannot have the entire row or entire column as 0. Why? Because if entire row or entire column is 0, then the determinant is 0. So you have to be very careful with that. I have made in row 2 elements 0. So now my calculation will be easier. So now I will be expanding through row 2. Expanding through row 2. So determinant is equal to half of, see, I can skip the 0 and 0, no? So directly I can take only 1. So what is the position over here? 2, 3. 2th row and 3rd column, no? So only I've taken like this. So this will be negative 1 into my determinant. What is my determinant? I have to hide this column and this row. So minus 5, 2, 6, 7. So this will be my determinant. So area of triangle is equal to half of minus 1 into, I will be using the x method. So minus 35 minus 12. So determinant is equal to half of minus 1 into 35 minus 12 is minus 47. So determinant is equal to half of, minus into minus is plus, so 47. So my final answer will be 47 by 2 square units. So that's it. This is my answer. Once more, I will just explain you why I have did this method, because I have to make my method simple. So only I am doing it like this. So however we do, if we do it directly also, we'll get the same answer 47 by 2. If we do with this method also, we'll get 47 by 2 only. See, there are lots of method that we will be learning. So you have to be very, very thorough with all these methods. So please do watch that video which I made for properties of determinants. If you have watched that video, it will be easy for you to do over here. Okay, so now this will be the shortcut method where we will be able to do it. If we do it directly also, but the method or the steps will be longer, the calculations will be longer. If we do it in such a way, the method or steps will be shorter, and it is an easy way to do the sums. Subdivision 3, here also 3 coordinates are given and we have to find the area of the triangle. So now let's mark x1, y1, x2, y2, x3, y3. So solution, what is the area of the triangle? Area of the triangle is equal to half of x1, y1, x2, y2, x3, y3, 1, 1, 1. So this is the formula. So now let's start substituting the formula. So determinant is equal to half of x1 is minus 2 minus 3, 3, 2, minus 1, minus 8, 1, 1, 1. So here, if you look into this determinant, we don't have anything that is common or can be subtracted. Okay, so I will be subtracting this and this and this, so that I can make some zeros over here. So what I will do is that row 1 implies row 1 minus row 2. Okay, so row 1 minus row 2 gives me 0 over here, and I need not to check other elements now. Here I will get 0, no? So that's enough. And row 2 implies R2 minus R3. Okay, so this minus this only we will be doing. And here one important thing, see, already we took R1 minus R2, so here we can't take R2 minus R1. Still now we have never did such sums, so you should not do that also. Okay, so R2 minus R3 I have taken. So now let's see the determinant. So determinant is equal to half of, so here R1 minus R2, no, minus 2 minus 3, which is minus 5, and here minus 3 is already there, minus 2. So here also minus 5. So here it will become 0. 1 minus 1 is 0 now. So next R2 minus R3. So 3 minus of minus is 3 plus 1. So 4. And here, so 2 into 2 plus 8, then it will become 10, 0, minus 1, minus 8, 1. We cannot change all the 3 rows together. Okay, so now I'm going to take this. See, in this first row, minus 5 is common. I have already taught you in the properties of introduction, no? So if I have something common, KA, KB, KC, then I can take this K out, no? So 5 into 0 is 5. Minus 5 into 0 is anyway going to be 0 only. So I will be saying that minus 5 is common over here in this row, so that I will be taking it out of the determinant in the next step. So determinant is equal to half of minus 5. I will take it out, and if I see here, in two tables it is common, isn't it? So I will be taking 2 out. So 2 into 2 is 4, 2 into 5 is 0, 2 into 0 is 0. So I will be taking that 2 also. So now how will I change my determinant? I took minus 5 out, isn't it? What is remaining? Minus 5 into 1 is minus 5. So 1, and here 2 2s are 4. No, so 2 I have taken out. So one more 2 is over here. And here minus 1 here, and 2 5s are 5. So 5 will be remaining 0, 0 as it is. And now I will have minus 1, minus 8, 1. So see now, do I have any minus signs over here? I have a here, but not here. No. So for calculation, only these 4 elements will be useful. Why? Because these two I will be skipping. So I will be using only this one in order to expand. Okay. So now if I expand, I have to hide this column and this row. So I will be using only these 4 elements, which is positive. So before moving on to the step, do you see here 2 and 2? 2 divided by 2 is 1. So these two I will cancel. So now, determinant is equal to minus 5 into, so now I'm expanding. No, I forgot to write. Expanding through C3, column 3. No, so now area of triangle is minus 5 into, so I will be expanding through these two I will be skipping. So 3 3, no, this position is 3 3, 3 plus 3 is 6. So this is even position, so it will be positive 1 into, what is the determinant? I will be hiding these two. No, so the remaining is 2 5 1 1. So 1 1 2 5. So now I will be using X method in order to find the area. So minus 5 into, so 5 ones are 5 minus 2 ones are 2. So area is equal to minus 5 into 3. So what is here? So triangle is equal to minus 15. So on the important note of area of triangles, I just gave you, no. So even if we have a negative number, we can take the absolute value for that area of the triangle. So what is the absolute value of minus 15? It is plus 15. So area of triangle is equal to 15 square units. That's it. Over. Question 2. Show that the points A, B and C are collinear. So they have given 3 coordinates of the triangle and they are asking us to prove it is a collinear. So what is a collinear? We have 3 points which has a straight line, which forms a straight line. Okay. So that is what collinear. So do a line have an area? No. So the area of the line will be 0, isn't it? So we have to prove that the area of the given points is 0. So now first let's write the formula. Area of the triangle is equal to half of x1 y1 x2 y2 x3 y3 1 1 1. So this is the formula, isn't it? So now I'm going to substitute. Before substituting, I'll just write x1 y1. This fully is y1. Okay, so x2 y2 x3 y3. Fine. So now I'm gonna substitute. So half of A B plus C, B C plus A, C A plus B 1 1 1. Okay, now what I'm going to do is that I'm going to simplify. See, till now we were learning only about numbers and all those. So did we come across any variables till now? No, we didn't come across any variables, isn't it? So now there are some properties where we have to use to make the determinant or find the solution for the determinant. Okay, so if you just look into the determinant, you will get an idea. See, what is that? Okay, so see, A B plus C. Just take the variables A, B, C. B, C, A, B, C. Everything is there. A, B, C is there in every element. These two columns. If we add ABC is there, but only thing is that it is jumbled. If A is here, A is not here, B is here, B is not here, C is here, C is not here, other two variables is there. It's just like that, no? So we will be adding column 1 and column 2. So now by the end of the question you will come to know why I added like this. So to make the determinant simple, we will be doing that, okay? So column 1 implies column 1 plus column 2. So my area of triangle is half of, so if I add these to A, B, C, no, so A plus B plus C, B, C, A. So I will interchange and write A plus B plus C. However, I write it same, no? So A plus B plus C, and A, C, A, B is there. So I will write A plus B plus C again, and this as it is. And this also as it is. So now I said no, if anything is common throughout the column or throughout the row, I will take it out of the determinant, no? So here A plus B plus C is common in all the three places. Now, so what I will do is that half of A plus B plus C. Okay, this is A plus B plus C. I took it out. So 1 into A plus B plus C only, gives this answer. So I will write 1, 1, 1. B plus C, C plus A plus B, 1, 1, 1. Okay, so now check here. Column 1 and column 2, column 3 are equal. That is 1, 1, 1, 1, 1, 1. So column 1 and column 3 are equal. So we have learnt a property that if any two rows or any two columns are equal, that is with the same elements or with a constant proportion, if the column 1 and column 3 are proportional, then we will say that determinant is equal to 0, isn't it? So I will say that column 1 is proportional to column 3. So then my determinant will become 0. So area of triangle is equal to half of A plus B plus C. So this is multiplication only, no? So I will have it as 0. Okay. So anything into 0 is 0. So therefore area is equal to 0 square units. So therefore, since area is 0, I will say that the points form a collinear. So since area of the triangle formed by the given points is 0 square units, it is proved that points A, B and C are collinear. That's it. Question 3. Find the values of K if area of the triangle is 4 square units and vertices of. So these 3 vertices are given, that is coordinates are given. And one more important note I have already said in the introduction part, in the area of triangles note I said, no. So only the absolute value will be taken as the area of the triangle. Okay, it can be negative or positive. Final answer will be in positive only. We will be taking only the absolute value. So here positive 4 is only given, plus 4 is only given, minus 4 is not given. But the determinant value can be either positive or negative. So that we will be taking plus 4 as well as minus 4 in order to get the value of K. So we will be having two values for K. So we can take any one. So now let's begin. Solution. First, let us write the formula for the area of triangle. x1 y1 1, x2 y2 1, x3 y3 1 there. So now here it will be x1 y1 x2 y2 x3 y3. So now I will be substituting in the formula half of what is the determinant k 0 4 0 0 2 1 1 1. So now it is very easy for me to expand the determinant through the column 2, expanding through C2, that is column 2, I will get. So determinant is equal to half of, so I will be having this only because 2 3 is the position here, it will be odd position, so minus 2 into my determinant will be k141. So now here 2 is here, 2 and 2 will get cancelled, so determinant is equal to minus of k ones are k minus 4. Okay, so determinant is equal to 4 minus k. I'm just taking the subtraction inside. So now already my area is given. What is my area? 4. No, so when an area is equal to plus 4, I will check. So here, so 4 is equal to 4 minus k. So k is equal to 0 when my area is 4. Okay, so now let me check for when determinant is equal to minus 4. So minus 4 is equal to 4 minus k. So when I take k this side, 4 plus 4, so my k will be 8 when my determinant, that is area, is minus 4. So my k value is 0 if the area is 4 and k value is 8 if my area of the triangle is minus 4 over. Second subdivision, here also they have given the 3 coordinates and the area is given as 4 units. Okay, so now we have to find the value of k. So already I have written the formula for that area of the triangle and the coordinates. So now let's start substituting. So determinant is equal to half of what is the values over there? Minus 2, 0, 0, 4, 0, k, 1, 1, 1. So here also it is easy for me to expand my determinant. So how will I expand my determinant? I will be expanding through column 1. So expanding the determinant through column 1. So determinant is equal to half of, I will be taking minus 2. Here it is 1 1 only, it is even, so but still here it is negative, so I will have 2 here into what is the determinant? 4 1 k1. So here also 2 and 2 will get cancelled, so area is equal to minus of, so 4 ones are 4 minus k. So I will have my area as k minus 4. Okay, so now I will take the area now. So when my area is equal to plus 4, I will have it as 4 is equal to k minus 4. So therefore k is equal to 8. K value is 8 if determinant, that is area of the triangle, is plus 4, and when area of triangle is equal to minus 4, I will have minus 4 is equal to k minus 4. So these two I will get cancelled, so k is equal to 0. So k is 0 when triangle area is minus 4. Question 4, first subdivision, find the equation of the line joining 1, 2 and 3, 6 using a determinant. So we have not learned anything that relates to line, isn't it? So they are nothing but they're saying about collinear points. 3 points will be there, so which forms a line. Okay, that is what they are saying over here. We will be using the area of triangle only. So triangle is equal to x1 y1 1, x2 y2 1, x3 y3 1. No, half of this determinant, isn't it? So we will be using this only to find the equation also. But only one thing is that the third point is not given. So I'm saying that let P be some point, x comma y be some point. Okay, so let this be some point lie on the given line, so that A comma B comma P lie on a same line. Therefore they are collinear. So if it is collinear, the determinant will be 0, isn't it? So therefore the area of collinear line is 0. So now we will be substituting in the area. So half of, what is my x? x1, y1, I'm taking it as xy. So xy 1 and 1, 2, 1, 3, 6, 1. So now I'm going to expand it directly. Why? Because I have variables over here and I can't do anything with this variable, keeping on subtracting and all. So I will be expanding through column 3, because I have one. No, it will be easy for me. So here, what is the position over here? It is 1 3. So this is even position. So area of triangle is half of 1 into minus 1. No, so this is even, so plus 1 into, so 1 2 3 6 minus 1 into, so this one, no, so x y 3 6 plus 1 into x y 1 2. Okay, so now I will have determinant is equal to half of, see, 1 6 are 6, 6 minus 6, this is 1, and minus 1 into, so 6x minus 3y plus, here it is 2x minus y. So my area is equal to half of 0 minus, so here it is, I'm going to take this minus sign inside, so minus 6x plus 3y plus 2x minus y. So what was my determinant for collinear? It was 0. So 0 is equal to half of minus 6 plus 2x is minus 4x, and 3y minus y is plus 2y. So now I will be taking 2 common. So 0 is equal to 1 by 2 into 2 into minus 2x plus y. So this and this will get cancelled. So what will I have? 0 is equal to minus 2x plus y. So I need not to have my. So now you can stop with this, or else you can just write, if I take this to this side, so I will have y is equal to 2x. This is the required equation. You can either stop with this step or you can prove it till here. That's it. Subdivision 2, here also we have to find the equation, and two coordinates are given, and we will be taking the points x and y as a third point. Okay, as we did for the previous subdivision, we will be doing the same thing. That only I've written here. Let the point p x comma y lie on the given line, that is a and b be some this points, given points, and such that a, b and p lie on the same line. Therefore, we will say that if it is a line, then they are collinear, isn't it? So, if they are collinear, the area is equal to 0. That only I have written till here. And I have written the formula for the area of triangle also. So, now we will start substituting the value of the determinant. So, let this be x, y, 1. And here it is 3, 1, 1, 9, 3, 1. Here also we will be expanding through column 3. So determinant is equal to half of, so here it is 1, 3, no? So this is even, so 1 into, so here 1, 3, 9, sorry, 3, 1, 9, 3 minus 1 into x, y, 9, 3 plus 1 into x, y, 3, 1. So the area is 0, we already said, no? So half of, so now I will be multiplying. So 3 3s are 9 minus 9 minus 3x minus 9y plus x minus 3y. So here 0 is equal to half of, here it is 0, so I'm taking this subtraction symbol inside, so minus 3y plus 9y plus x minus 3y. So now 0 is equal to half of minus 3y, and this is x. So minus 3x plus x is minus 2x, and here it is minus 9y minus 3y plus 9y minus 3y is plus 6y, and I will be taking the common terms out. What is common here? 2. So 3y minus x. So here I will cancel these two. So I will write 0 is equal to 3y minus x. So I will be changing the sign throughout, where I will have x minus 3y is equal to 0. So this is the required equation. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.